Acceleration. We want to talk about some introduction information about acceleration before we do any kinds of calculations. So when we talk about acceleration, we're dealing with a rate of change of velocity. It can be an increase in velocity, which we call acceleration, or it can be a decrease in velocity, which we call deceleration. So if we say we have an increase in velocity and we know how much that increases over time, that's our acceleration. And if we know how much a car is slowing down over time, we know what its deceleration is. An object that does not have a change in velocity has an acceleration of 0. So if we have a car that's moving at 55 miles per hour down the highway, and there is no change in its velocity, so it continues to travel at 55 miles per hour, it is not accelerating, so we say that its acceleration is 0. When we talk about the units for acceleration, we can either write them in terms of meters per second squared, or we can say meters per second per second. They mean the same thing. So think about this. You're driving along in a car, you're at a stop sign, and you start to put your foot on the gas pedal. The speed of the car increases, and you can see that on the speedometer on the dashboard. The acceleration is how much that car is speeding up per second. Let's look at our change in velocity equation. We know that that triangle stands for delta, or change in. So our change in velocity equals our VF minus our VI. Again, that delta V means the change in velocity, which is in terms of meters per second. The VF stands for the final velocity, and that's also in meters per second. And the VI is the initial velocity in meters per second. So let's look at a practice problem. Let's say that we have a car that is going 10 meters per second and it accelerates to 60 meters per second. We want to know what is the change in the velocity of the car. So the first thing we're going to do is write down our equation. We're trying to calculate the change in velocity, so we know that change in velocity equals our V final minus our V initial. Next, we want to write down what our variables are. So our V initial is 10 meters per second. That's how far the car is driving initially. Our V final is 60 meters per second, and we want to make sure we put those decimals in because that tells us we're looking at 2 significant digits. And now we're going to plug our variables into our equation. So delta V equals 60 meters per second minus 10 meters per second. So our change in our velocity is 50 meters per second. And since it's a positive number, it means that our car is accelerating. Let's look at another problem. A car goes from 125 meters per second to 0 meters per second. And we want to calculate the change in the velocity of the car. So we're trying to calculate our change in velocity. So we're going to take our V final minus our V initial as our equation. Our variables are, our V initial is 125 meters per second. Our V final is 0 meters per second. Now we're going to plug our numbers into our equation. So delta V equals, for V final, we're going to plug in 0 meters per second. For V initial, we're going to plug in 125 meters per second. And when we take 0 and subtract 125, our delta V is going to be negative 125 meters per second. That means that our car is slowing down or decelerating. Next, let's look at our acceleration equation. Our acceleration equation looks like this. We've got A equals delta V divided by T. Our A equals our acceleration. And our units for acceleration are meters per second squared or meters per second per second. Our delta V is our change in velocity. The units for change in velocity are meters per second. That value may be directly given to us, or we may have to use the previous equation to calculate it. And our T stands for time. And our units for time are going to be in seconds so that they match up with the units in our velocity. So let's look at a practice problem. It says, what is the acceleration of a rocket car that can change its velocity by 10 meters per second in 5 seconds? So it's telling us what the change in velocity is, so we know our delta V. It's giving us the time, and we're trying to calculate our acceleration. So we write our equation. Acceleration equals our change in velocity divided by time. We write down our variables. Our change in velocity is what we're trying to find, or sorry, our acceleration is what we're trying to find. Our delta V is 10 meters per second. Our T is 5.0 seconds. Now we can plug the numbers into our equation and calculate our acceleration. So our acceleration is going to equal, for our change in velocity, we're going to plug in 10 meters per second. For our time, we're going to plug in 5.0 seconds. And then we'll take 10 divided by 5. That'll give us 2.0. And our units are going to be meters per second, or meters per second squared. Make sure that when you practice these problems, you include all the steps in these problems. You write down the equation that applies. You next write down all your variables with your units. You plug the numbers into the equation. Then you do your math. Make sure you round to the appropriate number of significant digits, and you write units for your answers. Come back and listen to the video again if you're not sure how to do these kinds of problems.